Hi guys. Okay, so I did a quick review of this new digital multimeter that I purchased for my lab, which is a Hantek HCM3065, 6.5 digits, and we're going to be writing some software for it. And this is I did a diagram to give us a little bit of an overview of what that is going to involve. Now, the Hantek unit has some firmware in it, of course, and that includes a so-called SCPI interpreter, SCPI. We'll have a look at what that exactly means. There are commands that you can send through a device like a digital multimeter or an oscilloscope or whatever measurement instrument that you have. And in our case, we're going to be talking to it through the USB port that's on the back of it. And the USB port in turn connects to the Windows PC, but in order to talk to the digital multimeter, we need to install the Keysight I bundle, which includes the Visa drivers, which is actually what we talk to and what actually talks through the USB through the actual digital multimeter, and the language, the commands that we'll be issuing from the .NET application, C# application, is going to be SCPI commands, and it'll send values back to us according to the commands, or it will change the mode of the digital multimeter so you can control it remotely. So let's have a look at what it takes to get this information that we need. We need to find out how to talk to issue these Visa functions, and what kind of commands do we need to use in order to get information out and to control the digital multimeter. Okay, so this is part of the user guide that we have downloaded from the Hantek website. We'll have a look at that in a minute. Now, the unit came in a box with no information whatsoever other than a calibration certificate and a couple of cables, power cable and a USB cable, and that was it. So you had to download these things, and it tells you to go to this URL here on Keysight.com, software and so on. So if you click on that, you'll find that you are directed to the Keysight website, and they have this IL library suite, but at the very least you need to Keysight instrument control bundle download is what you'll be wanting. And other than that, on the Hantek website there's where the quick guide and user guide came from. I downloaded this software, but it's actually a CD image, and it is actually of no use to me right now. But this HCM3000 SDK is actually got some software that we can have a look at, which is it's got a C# demo here, and in there you will find the actual files here. Let me make this full screen. The form, it's got a form there with a couple of fields on it where you can connect and then send commands to it. And over here you get an indication of how you can connect with the device, and it has button send and read click. So it picks up this SCPI commands, read string, Visa instrument, read bytes. That's all pretty low level stuff. And then there is a Visa.cs file here, which actually gives you the actual commands that the Visa driver actually provides. Now this is a DLL, Visa32 DLL, comes with the Keysight I bundle, so you don't have to find that by yourself. And it has, all the commands that it has. We will be looking at that later. And also somewhere over here, this is where the actual attributes and error codes and so on hiding as well. Over here, there are success codes, warning codes, and error codes. And then they have this file called Visa.cs, which actually that's where that write bytes, and here it calls the Visa low-level functions from that DLL here in order to send information to the device. And it's got a read bytes thing here, which in actual fact looks a bit weird to me, but it works, so I don't challenge it. I have actually copied that and used it in my software. I'm a software engineer, and when people provide software, it might not look pretty, but if it works and I can test it and there's no problem with it, why change it? Any case, so that was useful to see how they did that. It gives me an indication of what's involved. And there are other files over here. Now I actually downloaded a hang on, I lost the folder here, clicked on the wrong thing obviously, and there it is. I've actually downloaded a file here, which is the DM3000 digital multimeter SCI programming reference. I have not found that file anywhere on the Hantek website or anywhere when I do Google searches or anything like that, but I searched for a document on the SCPI protocol for that multimeter, and you have to get the SCPI commands vary depending on what kind of device that you're talking to. If you're talking to a power supply, remote controlled power supply, or a oscilloscope, or a digital multimeter, or an LCR meter, whatever it is, all the devices that you will buy from these companies like Keysight and so on, they all have the ability to talk via USB on this or on the Ethernet or whatever interface that you have purchased, and you need to set the right commands to it, and the commands will vary and have different purposes and so on these different devices. So you got to get the specific commands that are available for your device. And I went to the EEV log or something, whatever that's called, where electronics engineers can talk. And somebody said, hey, I bought a HCM, the same model I have, 3065, and I need to remote control it, and I got this file. I don't know where he got it from, but it's all in Chinese. I can't read it, and does anyone have any information on it? So what I've actually done is I've taken that file. He actually was good enough to actually put that file to be downloaded from that log entry. This is what I did, and in actual fact I had it translated by the Google translator, and it did a pretty good job. The only thing is, when you do that, is the formatting, of course, is up to Greek. I could convert this to a doc file and edit it, but I didn't bother. There was only a few things I was looking for. These are all the commands that it has. I'm not interested in the calibration commands, but configure is important, and the sense one is important. and which is pretty much what we're going to be using. And then there is a couple of commands like read, that to read the values, and I got all that information from this document. And of course there is an external trigger that you can actually use to trigger readings and so on, but I'm not going to be using that in my software, so we won't be covering that and so on. So what we have then is multimeter is actually connected, and you can tell that by this over here. Let me zoom in a little bit here. So there's a device here, description, USB test and measurement device, IVI. There's different companies involved with these drivers and things, and that's IVI Foundation is one of them. The Visa National Instruments were one of them, and yeah, that's the IVI Foundation. So this is connected. Now note that the actual device is actually going straight to the USB port. Some of the other little devices that I have, like I have a O1 multimeter, which has also a sort of a fake SCPI interface. I say fake because the commands are a little bit unusual, but like many other cheaper devices, they use like an FTDI type chip to convert the USB to on the PC end to a COM port, and then of course you'd have to look for it on the COM port area, and then of course your interface is completely different. But in this case we are going directly through the USB port, and you can actually gain a little bit of information. This is the CN24301 and so on. That I think that is the serial number of the device and so on. Okay, so after you download this software, this control bundle, then I found that I could find some information on the Visa functions, and there's like I have highlighted VI read. You can actually read data from the device. Comes back with the status. The status again is defined in here, and the information how to call these things are discussed in this document. So that is a handy thing to have, because you will be at the lowest level you will be using these Visa commands. They originally came from National Instruments, but I think they've been taken over by another company now. They have these are operations are the functions that it supports. There are attributes, there's error codes. These error codes here, remember, are also defined in the software. We'll look at them again in a minute in that Visa CS file that talks to the DLL. This is the I wrote some software quickly to test it, and as I said, this is the Visa 32 file. You looked at the Hantek version earlier. I've done some editing on it. I put this comment there, and I put a link to that document you just saw at the ni.com for information on these calls. But we are interested in several things, like here is those error codes I just mentioned that you also saw on the Visa website. You'll notice that a few of them are actually not error codes, they are success codes, and they're all positive. There are warning codes, they're also positive, but error codes are always negative. So I've actually added this thing. It's kind of machine generated, but the numbers are not consecutive, so you can't say, oh, if it is within this range or that range, you have to mention them all. But it comes back with a whether it's an error over here, or it's a warning over there, or it is a undefined if it's a number that is not known, or it is a okay, so it was success. That's the only changes that pretty much that I made. But the biggest change was that I've created this SCPI file. Right now it's one file, but I'm about to split that up into several different files. Right now I'm calling these things from within one area, so I am in the habit of putting all the classes and things in one file, but I am going to split those for the software that we're going to write later, which we'll discuss. This is just the test stuff. I put some comments here, where to get the downloads for the I/O software from, what SCPI is all about, the commands that we will be using. They will start with conf colon, read question mark, and sense colon. Those are the main three that we'll be using, and syst ERR question mark to get error codes. And we've got to convert the actual data that we get back is always going to be in this exponential or exponent rather format, and if we get a value back that looks like this exactly, that means it's overload, and we've got to change it, not display the value but say overload or open if it's continuity and so on. So because we're picking up these errors with that command over here, we have to put those somewhere. So I created a class called error item. Now the errors always come in the format of like this. You saw the error codes earlier. If it's positive 0, it always has a plus or a minus in front of it. And the message says no error. That means there aren't any errors in the error queue. It maintains an error queue on the SCPI Visa end that you can actually query one at a time. It's a FIFO buffer, first in, first out. So if you read from there and it says 0, no error, then you know there's no error. But if there is an error, then this will be a negative number, and there would be some message there, and often the messages don't make much sense. It will say unknown header instead of unknown command, and stuff like that, which maybe we will interpret, but I haven't done that yet. We'll look at that later. So we therefore have an error item that will have an error ID, that's a number, and a description. So if it is no error, it would have 0 there, and it would say no error. And in that case, I also added a little boolean here that if the error ID is 0, then if it's not equal to 0, rather, it is an error. Now it could be a warning or a another kind of message, but I am specifically interested. I'm probably going to rename that. I should say is end of file or something like that, because that's really what that is doing. But in any case, as I said, I'm still making some adjustments to that. Then, because it is a first in, first out buffer, there can be multiple errors, and they will all be in a list. So therefore, I created an error list. Doesn't have any extra properties right now, but in future there might be, so it was better for now to define an error list rather than just use a list of error items. Then there's an enum, a convenient place to record what mode the device is in, whether it's measuring DC voltage, AC voltage, resistance, amperage, frequency, capacitance, and so on and so on. Then the results that come back, rather than have it as a string, they get interpreted and converted to a actual value that can be displayed. Because remember, you get these that number like plus or minus a number and an error message for the errors, but the actual value for that you're reading back is going to be has an exponent on it, and it's got to be converted to a number that you can display. You have to make adjustments to it for, are we talking volts, millivolts, microvolts, and so on, and you can see that happening here. I overrode the toString value here, or I created the toString value, and I'm first checking if the query value happens to be that value. Remember, I said that means that it is either overload or open, as you see happening over there, or otherwise just this return the value. Depends on what mode it is in. If it's in all these modes, the appropriate thing would say the overload. If it's in continuity or diode mode, you can say open. And then make adjustments to the values. I'm still looking at this. I think I need to make a few more little adjustments to that. Maybe for capacitance or something, because I know that some very small capacitances came up with something that didn't make any sense. Anyway, side point, this will be working by the time you see it in the next episode of this series here that we are working on this software. There's going to be multiple episodes here, and I'll put them all in a view list, and I'll call it Hantek DMM. So you can look for that. Make sure you're subscribed and that you get notified. In any case, if it's voltage, then we need to determine the unit and adjust the value for potentially microvolts, millivolts. If it is ohms, then we want to know if it is ohms, megohms, or kiloohms, and make adjustments again to the value so it displays properly. If it's amps, it's the same as the voltage actually, microamps, milliamps. If it's hertz, there is no changes, it's always going to be in hertz. Didn't bother about kilohertz. Don't expect to use this in my YouTube videos. I have other devices that do frequency that are much more accurate and so on, and go high. This thing goes up to 300 kilohertz, and I need to go up to megahertz and all that sort of stuff. Anyway, I am rambling on. Anyway, this capacitance, we now want to know if it's microfarads, picofarads, nanofarads, and so on. And then finally, we convert the actual value, and if you hadn't noticed it yet, we are converting the value here to a double from the string value that we have, and we are going to go and format it. And this is going to be, right now this is a format, but that will probably change by the time I use it in the actual final software. But for the little console test application, this is a good way to do it. The value and the unit that we assigned over in this area here gets displayed, and if all else fails, if it's not a number, then just return the string, because it must have been a message of some description. And most of the work is done in this class that I created here, SCPI device. When we open a session, we will have a session ID and a resource manager, and there will be a device address and a device name. And if it is opened, there's an open command, then it will be ready. That will be true then. And this is a place to store the measure mode. we will, when we change the mode and we query it the first time around, then that will tell us, measure mode, what it is, and then of course there's a static thing here to get measure description for when we want to display it. I think it is probably used in here somewhere. This measure, oh, it's actually passed in as a measure, so it's at a higher level. It is passed in. In any case, that's where it comes from. So if it is measure mode DCB, then it's voltage DC, voltage AC, and so on. So then all those little private fields here are exposed as properties. I want to skip through this software as quick as I can, because we will go to this in more detail later on when it is all totally finished. Close. Here you get the measure mode from the device. This is the command sense func question mark, and it'll come back with a string, either volt AC, diode, current AC, and so on. I didn't like those, doesn't make much sense to me. That's why I created this enum there with the values there. Note that I am expecting, and I'm not going to be dealing with, I can, but the next software we're going to be writing is that this screen display for YouTube, and there I don't care about that. When we're talking about DC amps and AC amps, there is different modes there, 3 amp and 10 amp mode, depending on where you got the probes plugged into. It's always going to be expected to be in 3 amp mode. And when we're going to resistance, we do support the 2-wire and the 4-wire mode. So that's what we're going to be worried about. Now there is a status byte, and the status byte actually tells us if there was an error, if there are one or more errors in the error queue, and this is the bit number 2. These other bits have meanings as well, but we are not interested in them. This bit over here, I think, actually tells you whether there is some data waiting for you to read using the read command. But I found that if you do issue the read command, if there is nothing there, it'll just be empty. So what the heck? Don't have to get the status byte in order to find that out. And yeah, so it's read status byte, and it actually tests whether that bit is on over here, and error bit is on, will be actually be set if it is on, and it is passed as an out value, but the byte are passing the byte back as well. Okay, and get the error messages from the queue. You do that by the command system error question mark. As I said earlier, it just goes through a loop here until it finds that message that says 0, no error. And this stuff here is similar, but I did modify it from the code that Hantek had, write bytes. You can write it as a string. That's the low level stuff, but it has to be converted to a byte array, which is what it does here, and then it sends it to this method here to use a data array. So that's at a lower level. That's how the commands actually get to be written to the USB port to the device. And similarly, this code here, as I said, I only made a very small change to it. This bit over here to actually return a string empty. It came back with error or something like that. I don't really care if it didn't find anything. As I said, to read, then just don't come back with it at all, and just return string empty. And if it did find something, it has to be converted to a string, so then it can return the string. This is a lower level the next level up from what you saw, the write and the read, send and read, because 99 times out of the commands you would be wanting to get a value back, so you would send it and then do a read afterwards. And if there were errors, then return the list of errors. But this is at a lower level. Then there is a read value I'm not using right now. It's actually kind of like it just reads. You can use that if you sent a command and you didn't want to read the value straight away for some reason. As you will see later when we test it, possibly when we read capacitance, you send the command and actually perhaps wait a little bit and then do the read, because if you read straight away, you'll find that the capacitance can take a little time for it to settle, and you will get a reading that's not quite correct. And you have to read again, and then you get the correct reading. So perhaps, as I said, that's why I created this value over here. And so this is still experimental, and I think there will be some changes when we get to the final software. But for now, for testing, this is plenty good enough. So we can do a send and read, and remember we get this query value back that I created that will hold all the values and in a convenient way, and it can convert it for display and stuff like that. You send it to command. Measure mode is potentially null, and as you'll see over here, if the mode is null or the measure mode happens to be none, hasn't been set yet, then we want to know what mode the digital multimeter is in. So we will get the measure mode from this function here that I wrote. But if you already know it, you can actually pass it in, and it won't be reading it, and it'll just use whatever you passed in. And of course, that would be the case most of the time, because you will set some sort of mode on there. And once you know what the mode is, you're just doing readings, so you're not actually wanting the thing to check what the mode is each time. That would be a waste of time. And the rest of it is to open sessions and to find devices and to find and open a device. This is what we're using in that program over there. Okay, so we can test it out a little bit now and issue some commands and see what it does. So we can actually run this, and so if I say run it without compiling, we'll get this little window here that we can enter commands in. Text could be a bit bigger, I guess, but I'm sure you can see it. And let's bring in the actual camera that is aimed at the multimeter there. So I don't think we need to see the code right now. Well, as you can see, the first thing we're going to do is find and open a device. And if we found it, we're going to display the device name. And then it'll say enter SCPI command, and it's just a loop that uses that send and read. And if it found something, then it checks if there's errors, or it will display the errors and it'll display the result. Simple as that. So let me see, move that up a little bit. Okay, so you can already see that it has found the device as soon as we ran it. Hantek HCM3065 serial number, I believe that is, and that is the firmware version number 2006. And this is, it got that from that command here. And now this current DC actually is because I put that in. if the measure mode is null, as I said, it actually asks for the mode, and it's detected that it is in the current DC mode. You can actually do a conf question mark. These are all SCPI commands, of course, and I got those out of that document that I showed, and I will put links. All the software will end up in my GitHub site, and there will be links in the description to documents and things as well, so you can all check all this out for yourselves. It would be relatively simple, I presume, to convert this software to actually do more and to talk to oscilloscopes and other devices. So this might help you to get a handle on how to do that. In any case, I just did a conf question mark, and it tells me that it's in the current mode. And these two values here, I think it has to do with the range that it is currently set to, and what the actual value. I think it's just a range minimum, something like that. I'm not using these values, so I haven't actually investigated it fully. Alright, so I can say conf volt, let's do AC, and now you will see on the screen there that the AC voltage there is actually that it has selected AC voltage. Note that it's no longer triggering. You now have to trigger it yourself with a read command, and it'll only trigger once for each read command. So in our final software, what we actually do is, and that's kind of normal for these kind of remote control scenarios, maybe 3 times a second or 4 times a second or whatever is appropriate. I will just issue a read command and update the display on the screen. Now also notice here that it actually says remote. I think you can just see it. On the camera, of course, those screens are never as clear as what they are to the naked eye. Now note too that we are in auto range. We can actually change the range with that sense command. I'm not planning to do that, as you will see in a minute when I actually let's do a read. I've got nothing. I've actually got a little capacitor connected to I don't know what that's going to do right now to the probe. Oh, I am not typing on the right screen. So you saw that it actually did a read, and it quickly adjusted itself to the 100 millivolt range because it's in auto mode. But for some reason there is no value there. What happened? That I messed something up in the code? Obviously I did. So hold on, let me check what's going on here. Okay, I'm not sure what happened there. I turned the multimeter off and back on, and now it is working. I have noticed that I believe that there are some bugs in the firmware on this particular one, and if you certain errors at different times can cause the thing to lock up and not respond anymore on the SCPI code that you sent. The values come back blank and all that kind of stuff. It is quite possible that there is another error condition. As I said, there's status bytes and so on. They have additional bits I need to look into, but I think there might be some bugs there or something. But I did notice that if under normal circumstances, if you send the right commands with no errors and it seems to behave all right. So in any case, this is what we've got. We've got 23.722 millivolts AC, and this is what we're displaying. And of course, it came back with plus 0.23 blah 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 blah, minus E something or other, but we've converted it, and we are displaying the right value here. And as you can see, it actually has, it always comes back with more digits, and I've already stripped some of them off. It will have 3 more than what you see on the screen here, than what they display on the screen of the actual multimeter. I might pare this back so it displays exactly the same thing. I wish they would also drop the leading 0 on the multimeter. I don't know why they always have to put 0, 2, 3. Is that laziness or is that some convention? I'm not sure of. But in any case, I just disconnected the little capacitor that it had on the end there. So what happens if I do a read now? Pretty much the same. Just noise, picking up noise. PC mode. (8.7951), 8.79507. It obviously rounds it up when it displays it on the screen there of the multimeter, and because it's in auto range mode, it doesn't always, when you go to resistance for instance, it doesn't always round it off the way that I like, but I do it in my software. So let's go to resistance mode, conf, I think it's RES, and RES goes to the 2-wire mode. If you put FRES, it goes to the 4-wire mode, but we want 2-wire mode. So now if I do a read, it should say overload, because that is what it says on the screen. That's what we've got. Alright, and now I've got a little box here with a very old CR substitution box. It's like, I would have bought this in probably 1976 or something from Radio Shack. It's a Micronto one. It is very old and it's been in storage for many years, and the switch on it has got corrosion and the components probably have drifted over all those years, so but it still works up to a point. I've got to clean it out and actually do some work on that thing, I think. So let's hook that up to resistance and let's have a look. This is 10,000 ohms. So we've got 10,738.3. Again, we got that right. So we've got kilo ohms there that we are converting. And if I put it to, now we should be able to get, was it 10 mega ohms or something? Yep, 10 mega ohms. Now these digital multimeters, those the expensive ones like this 6.5 digit ones, they can usually read the resistance and voltage and current and the common things that these things, normally they're hooked into test circuits, and they can be automated, like with a software like LabVIEW and so on. You can write whole scripts, and they are very accurate in those 3 modes, but capacitance and frequency and so on is not something that you normally, they add those features to it, but then they are not really, frequency only goes up to 300 kilohertz, and the the capacitance only goes up to 100 microfarads, which is next to nothing. And so you don't really use those things for that. You just want to be able to have really accurate resistance and voltage and so on reading. So this thing can probably handle many hundreds of megohms probably. In any case, let's come back to the kiloohm setting, and let's try a low resistance. What if I just hook the probes up together? I should just get some milliohms or something. Keep on. Actually, I think I can hit F3, don't I? Yeah, don't have to type it each time. Okay, so we've got 46 milliohms, and it's displaying it the same way. It says 46 there, but we have 4596. I'm presuming that the values I'm getting are more accurate than what is on the screen, maybe because it's got more digits. Any case, that's working. So we should actually be able to use this multimeter for reading right down to as a milliohm meter, but I've got dedicated milliohm meters which I would prefer to use. They have extra features. You can zero them out and stuff like that. Okay, put this back on. I'm just hooking up the CR box again. Now over here, let's go to 100 ohms, and you will see that I'm displaying this as 130.31917, but the actual multimeter, because it's an auto range, if I take it out of auto range and tell it to go to ohms range, it will change. But it says it's 0.13130.319 kiloohms. This is kind of surprising. You think that they would show it in ohms as well, like I'm doing over here, but in any case, it doesn't matter. As I said, when you take it out of auto range and put it in, right now it says auto 1 kiloohm. If you put it on auto 1 ohm, then it would actually display correctly anyway, but we're going to be displaying these values on our software on the screen, and I will have it in ohms. Okay, so that's that, and then of course I've got a 100 nanofarad capacitor here, and as I said, the capacitance mode is not something that I expect to actually be using for the on-screen software. I have LCR meters and things that I use for capacitance, which are more accurate, and also well, even if they're not more accurate, I don't really know how accurate the capacitance is. I haven't looked it up, but they are quicker and they can measure, up to the millifarad range. Boy, I've got these little crocodile clips here, and they don't want to hook onto short leads. Okay, so now I go to, I think it's just const cap. Yeah. And okay, on screen it says 100.93 nanofarads, which is exactly what we will be expecting. And now I did another read that says 99.5 nanofarads. I do another read, I actually typed key bounds 2 R's, and now you can see how the errors are reported. Undefined header, it says. It just means that it doesn't know what the command is. 98850. That's exactly what we've got that it reads. Okay, so anyway, so anything else that is of interest? Let me look on my list here. As I said, there are some features there that I am not actually interested in. For instance, if I really wanted to sense current, first I would conf, I think that's what the command is. Yep, now we're in DC current mode, and if I now go, this is the sense command, current DC term, I don't know what, it actually tells me that it's the probe should be in the 3 amp socket, not in the 10 amp socket, but I can actually change it. I can say sense current DC term and then put I think 10 or something in quotes, but I'm not going to go there because let me see now. I think that's probably all that we are interested in. It's got a temperature mode, but I don't have temperature probes for it, and I've tried some of the temperature probes that came with some other multimeters that I have. They don't work, so I don't expect to use it for that, and if I do, I'd have to buy some probe somewhere or find out what it is and make one up. I don't know. Okay, so that's it. That's as far as we are going so far, and now next we're going to actually go to the next level with the software, and I have not completely started that. I have did the test. I wanted to be able to this is the one here. I wanted to be able to display the numbers with a transparent background as an option, and this is the test, and this is going to be the starting point. I'm going to import, you know, that SCPI.cs file, class file, and all that kind of stuff. But when I run this, this is my test. You see, it's got like a transparent background. You can kind of put it on the top there, make it bigger, smaller, whatever. This particular, I can close this now. This particular software, of course, is going to have, this is going to be a menu here, little hamburger thing. I'll put it closer to the number, and it's got to have the unit there as well, eventually, and so on. And there'll be over here, we have to list, like, you know, what it is, voltage, capacitance, resistance, and so on. But either the menu, or I'll put some buttons on there to change the modes, you know, to voltage, capacitance, and resistance, and not capacitance, voltage, current, resistance, and continuity, and so on. And diode mode, that's the 4 modes that I really want to be able to have on there. So that's it. So this works. As I said, it's transparent, but that'll be an option that'll be on the menu that you can actually choose the background color and all that kind of stuff. So that's it, guys. In the next part or episode or whatever you want to call it, we are going to do that software, and I will continue to do some testing. I want to make some adjustments to it, and then we go to the next step and create that software. So don't forget to subscribe and like, and there will be a view list. It will be called Hantek DMM, so they will all be together, and I'll see you guys later.